So the whole point of having the right amount of atoms is because you have to balance out your law of conservation of mass. Okay, so let's go ahead and oops. Oh. Okay, here we go. So now, when you have a complete compound, and especially one that has different elements, remember that the numbers are going to be very important. Okay, so let's do that with a different color. So if I had something just like NaCl, the fact that there's no number means that you have one sodium and you have one chlorine. Okay, so when you have no number like this, you automatically have one. So here for sodium, you have one sodium. Carbon, you have that little subscript of 2, so you have 2 carbon. Hydrogen, you have that 3, so you have 3 carbon. And oxygen, you have that 2, and so you have 2 carbon. Now, the way this can change is if you have parentheses or a number in front, and that can change the subscripts that are there at the bottom. Okay, but for now, when you have a compound like this, you just go by the number that you have at the bottom, assuming that your coefficient is 1, and that's what gives you these totals right here. Okay, any questions so far? Are we okay? Okay, now, if you have parentheses, that's going to be a little different. So here we have aluminum, we have sulfur, when we have oxygen. Okay. So now aluminum, what's my subscript for aluminum? 2, very good. So that means you have 2 aluminums. What's my subscript here for sulfur? 1, very good. Because there's no number at the bottom, that means you have 1 sulfur. But now, because of these parentheses, this 3 is going to multiply to everything inside your compound. So it's kind of like the FOIL method in algebra. That outside number multiplies to everything on the inside. Same thing here. So that means that 1 times 3 is going to give me how many sulfur? 3, very good. And this 4 times 3 is going to give you 12 oxygen. And that's your total atoms. Okay? Who's not okay? We good? Yes? Okay. I told you, it's super easy. Okay, now, when you have a coefficient, this number in front is always called your coefficient. Okay? And this is what you're going to have in the balancing reactions that we're going to be having this week. Okay, so the coefficient is going to kind of behave just as the number outside of the parentheses. So here, nitrogen, I have 1 of them, but this 2 is going to multiply in here, right? So how many total nitrogen do I have from the parentheses? 2, very good. Now, because I have 2 nitrogen, and then I have that coefficient, 5 times that 2 is going to give me 10 total nitrogens. Okay? And same thing with a hydrogen. 2 times 4 is going to give me a total of what? 8. Very good. And then that 8 times that 5 is going to give me 40 total atoms of just hydrogen. Okay. Now oxygen here, how many oxygen do I have? How many oxygen do I have? Just 1 on the compound, right? But because of this coefficient, now that 5 times that 1 is going to give me a total of 5 oxygen for this compound. We see that? And that's only when you have the coefficient up front. And you're going to be having that with the chemical reactions. Yes? Okay. Any questions? Okay, let's go ahead and look at the worksheet that you have today. Go ahead and pick one and let's do it together. Number 2. Okay, here you have strontium. and the subscript is a 3, but do I have a coefficient in front? Yes, so 2 times that 3 is going to give me how many? 6. So strontium's total is 6. Very good. Now phosphorus, don't forget, you have a compound. So this 2 is going to multiply to the P, and it's going to multiply to the O. So how many phosphorus do I have just here in the compound? 2. Very good. And now we're going to add the coefficient. So 2 times 2 for phosphorus is going to give you 4. Good job. Now for oxygen, you have 2 times 4. What is that total? 8. And then you're going to use that coefficient in front. So 2 times that 8 is going to give me 16. Very good. And so that's your totals for number 2. Okay? So now let's do one that's a lot easier. We need to be here on time. Okay? Okay. So now you have 3 N4O10. Or let's do one without a coefficient. Let's do number 6. Calcium. Does it have anything at the bottom? No. So how many calcium do you have? You have 1. And so you just have 1 calcium. That's it. Now, acetate in here is inside parentheses, and there's a 2 on the outside. So that 2 is going to multiply to everything on the inside. So 2 times 2 carbon gives you how many? Yep, you're going to have 4. Very good. Now you're going to do the same thing to each one. 2 times 3 for hydrogen. 6. Very good. And then 2 times 2 for the oxygen is going to give you 4. Very good. And these are your totals for a compound without a coefficient. Okay? What questions do we have? Remember, your whole objective here is to know how many atoms you have of each and every single different element. Okay? We good? Yes? Okay, yes?
Number 7, because there's no parentheses. How would you do that?
Oh, very good. Yes, number 7, there is no parentheses. So let me erase this, that way we can see it a little clearer. Okay. Your coefficient in front still multiplies to everything in that compound. So for sodium, you have 1 because there's no number, right? So 12 times that 1 is going to give you 12 of that sodium. And then for bromine, also, you don't have a number, and so that means it's a 1. So 1 times 12 also gives you 12 bromine. Okay? Good deal. That's true. Sometimes you can have a compound that doesn't have any subscripts, but if you have a coefficient, that coefficient always multiplies to every single element in that compound. Okay? Any other questions? No? Okay, you're going to do both sides, and